All right, so number one is what kind of a reaction, because that's obviously our first step here. It's a combustion reaction. And I know it's a combustion reaction because I see carbon and hydrogen reacting with oxygen. Okay, it's a hydrocarbon combustion reaction. That's actually the full name for them. All right, so anytime I have carbon and hydrogen together in a molecular compound, it is a hydrocarbon. Okay, reacting with oxygen. The products of all combustion reactions are the same: carbon dioxide and water. Okay, and that is if the combustion is perfect and clean and all that kind of stuff. Obviously, in the real world, we get other things. We get carbon monoxide. We get, other things that are in the fuels. All right, this would be in the perfect world. All right, so now I've predicted the products. I know that this is a molecular compound and its formula is right. Same with this one. All right, so now I've got to look at the balancing. Remembering that combustion reactions have special balancing rules, I want to balance alphabetically as rule number one. And if I have an even number of carbons, I want to start with a 2. So I've got to apply both rules here. All right, 2 times 8 is 16. So I'm going to need 16 carbons here to balance my carbons. Next thing alphabetically is hydrogen. All right, 2 times 18 is 36. 18 times 2 is 36. So now my hydrogens are balanced. Now I look last at my oxygens. I have 18 oxygens here in the water, okay, and I have another 32 of them here in the carbon dioxide for a total of 40, no, 50, okay? 25 times 2 is 50. Okay, these are just the kind of things that, like, we want to get to the point, guys, so that on Monday when you're writing your unit exam, this is just habit, okay? It's just a matter of patterning, okay? I know that combustion reactions follow this pattern, so I follow the pattern, right? Similar with number 2. Right, if I look at number 2, I've got sodium phosphate, which is an ionic compound, a metal and a polyatomic ion, and then I've got lithium oxide, metal, non-metal, so also an ionic compound. I only have one reaction type that starts with 2 ionic compounds, okay? And that would be what, Sam? What kind of reaction is that? Double replacement. Okay, so now I have to remember patterning. What happens in a double replacement reaction? Well, I get 2 new ionic compounds by doing what with the metals? Switching them. Okay, so I will have lithium ending up with phosphate, and I will have sodium ending up with oxygen. All right, I've just I've just produced 2 new ionic compounds. And what do I have to do with all ionic compounds? Alyssa, what do I have to do? I have to swap and drop. All right, so phosphate is a -3. Lithium is a +1. So I'm going to need to go Li3PO4. All right, this one here, I've got oxygen is a -2, sodium is a +1. So I got Na2O. Now that I've done that, my last step is balance the entire reaction. I would say I can start with either lithium or sodium. They're both present as a 3 here. Okay. I've got 3 lithiums on this side, and I've got 2 over here. The lowest common multiple of that is 6. All right, so I'm going to put a 3 here and a 2 here to make 6 lithiums on both sides. When I put this 3 here, that gave me 3 oxygens. So I'm going to go over here and make sure I have 3 oxygens. Okay, that gave me 6 sodium. So I'm going to go back over here and make sure that I have 6 sodium. That gives me 2 phosphates, which I have, okay, and I have everything else now balanced. Okay, everybody all right with that one? How many people have done number 3? All right, let's have a look at that one too. All right, so in number 3, I've got phosphorus, okay, an element, in this case a molecular element because it comes as a 4, and then it's reacting with calcium nitride, metal, non-metal, so it's reacting with an ionic compound. All right, so I have an element reacting with an ionic compound. So Ethan, what kind of reaction is that? Number 3, yeah. Single replacement. All right, in a single replacement reaction, I have to figure out, as my pattern, what the element that's alone is going to switch places with. Okay, since this is a non-metal, it has to switch places with the other non-metal. Okay, in this case, it has to switch places with nitrogen. So nitrogen is going to end up alone, and phosphorus is going to end up with calcium on the other side. All right, so I'm going to have nitrogen alone and calcium together with phosphorus. All right, with single replacement reactions, I have to check for two things. Special elements, do I have one? Yes, nitrogen is a special element, comes as a 2. Okay, and ionic compounds that need to be dropped and swapped, which I also have. Okay, calcium is a 2+, phosphorus is a 3-, so Ca3P2. All right, now that I've checked for special elements and dropped and swapped my ionic compound, now I can balance the whole reaction. Again, I would probably look at balancing the biggest number first. That would be phosphorus. Okay, to do that, I would put a 2 here to give me my 4 phosphorus. When I do that, it gives me 6 calcium. So I got to go back over here and make sure I have 6 calcium, which then gives me 2 times 2 is 4 nitrogens. So a 2 there will balance my nitrogens. All right, so it's patterning, patterning, patterning. I have to know the patterns of the 5 reaction types. Okay, that's what allows me to figure out, well, who's going to go with who, okay, and get that stuff right. How many people have done number 4? Okay, let's look at that one too then. All right, so I've got chlorine, and it's reacting with potassium. So 2 elements are reacting. Okay, so what kind of reaction is that going to be, Carla? It's a synthesis reaction. All right, this synthesis reaction is going to create what kind of compound? Ionic. Potassium is a metal, chlorine is a non-metal. What do I write first? Metal. All right, this is a -1, this is a +1, so I drop and swap. It's good the way it's written. All right, now I just need to balance everything, which requires a 2 here and a 2 there. So the only real tricks with synthesis reactions are special element on the reactant side and making sure you write it in the right order. Okay, other than that, they're pretty straightforward. Okay, and then how many people have done 5? All right, so let's do that one too. All right, so for number 5, I've got disulfur trioxide, okay, and it's the only reactant. Okay, so Thalia, what kind of reaction is this? This is a decomposition reaction. All right, so that's going to result in the formation of 2 elements. All right, any special ones in here? Both of them, right? They're both special. Sulfur comes as an 8 and oxygen comes as a 2. How important is it to remember that? Crucial, absolutely crucial. All right, now we got to balance the whole reaction. So I'm going to go over here and balance my sulfurs first by putting a 4 in front of this because that's the biggest number. Okay, and when I do that, that gives me 4 times 3 is 12 oxygens. So 416 is what it looks like to me. Okay, so again, it's just about patterning, and that seemed to be when I was, marking your guys' reaction assignments. That was the patterning that was getting people forgetting to do certain steps, especially drops and swaps and special elements. Okay, those were where people got burned quite a bit. In writing out names and writing out formulas, it was more about Roman numerals. Okay, that was the place where people got caught, especially when writing names. Not so much when they had the names. They remembered what the Roman numerals were for when they had them, but when they had to put them in, that's when people forgot them. So we have to remember those as well. All right, I want you to try the last 5 here, okay, and then we'll talk a little bit more about Monday's test. Okay. Okay, so for number 6, I've got copper, and it's reacting with lithium chloride. Okay, so I have an element, and it's reacting with an ionic compound. What kind of reaction is that, Andrew? Single replacement. Okay, so in a single replacement reaction, I have to figure out who the element is going to switch with. Who is copper going to switch with? Lithium. Okay, so lithium will end up alone. And copper will end up with chlorine. Now, here's one of those weird things that comes up once in a while. Copper has more than one possible charge. I'm not told which charge it is because it was an element when I started and it didn't have a charge. So which charge do I pick, 1 or 2? Right, I picked the most common one, which is the one listed first. okay, and that's 2 plus. All right, then I can drop and swap this compound, okay, to be CuCl2. All right, so there's a few things, you know, those little situations that come up once in a while that we have to remember. Okay, now that I've done that, I can go back and balance the whole reaction with 2's there and there. Okay, questions on number 6? All right, number 7. I have potassium permanganate, and it's reacting with iron 2 sulfide. Liam, what kind of reaction is that? Double replacement. Okay, in the double replacement reaction, I will produce 2 new ionic compounds by doing what? Laney, what will I do? I'm going to get 2 new ionic compounds. How am I going to get them? By doing what? Swapping the metals. All right, so iron will have a new partner in permanganate. Okay, potassium will have a new partner in sulfur. Since these are both ionic compounds, they need to be dropped and swapped. Permanganate has a -1 charge, and iron, in this case, must have been its +2 charge because it was even with sulfur, which is -2. All right, so +2, that means I put brackets around the polyatomic ion, and I put a number outside the brackets, in this case a 2. Okay, sulfur's a -2, potassium's a +1, so this will be K2S, right? And now I've got to go back and balance the whole reaction with a 2 there. Okay. All right. Number 8 is what kind of a reaction? Alyssa Elliott. Synthesis reaction. All right. So in the synthesis reaction, I'm going to create, in this case, an ionic compound because hydrogen will act as a metal. Okay. So hydrogen and nitrogen will end up together, and I have to drop and swap it. This is a -3, it's a +1, so I'm going to form H3N as a result of this. Okay, now I need to balance the whole reaction. I would say that probably putting a 2 here will help that. At least it balances the nitrogens and gives me a number of hydrogens that I can also balance. All right, number 9. Jeremy, what kind of reaction am I looking at there? Okay, combustion, because I have carbon, hydrogen reacting with oxygen. Products are always the same. Carbon dioxide and water. In this case, I don't need the rule of 2 because I have an odd number of carbons. So I'm going to put a 5 here. Okay, I'm going to put a 6 here to balance my 12 hydrogens, and then I'm going to balance my oxygen. 6 plus 10 is 16, so an 8 there will do it. All right, and my last one, okay, number 10 is what kind of a reaction, Ethan? Decomposition. All right, so I'm going to form 2 elements, hydrogen and phosphorus. Either of them special? Both. Hydrogen is a 2, phosphorus is a 4. Okay, we'll balance the phosphorus first. So a 2 here will balance, or sorry, a 4 here. We'll balance the phosphorus, okay, and then I'll need a 6 here to balance the hydrogens. All right, just making a little bit more sense. Okay, just remember, guys, patterning. When you're working on this weekend, and you should be working on this weekend, okay, think about patterning. All right. The other thing, judging from the reaction assignment, that we need to practice a little bit is naming and writing formulas. All right, because if we don't get those right, all of what we went over today about patterning is meaningless because you won't get the right formulas or the right names. All right, so we need to make sure that we're doing that correctly as well. Okay, so those are 2 big things I think we need to practice. Looks like we're good with the mole equation. Okay, yesterday's quiz went pretty good. We seem pretty confident with that. You guys' math skills are good. Okay, so that won't be a problem. That doesn't mean don't look at a mole equation question all weekend. You still should. Obviously, there's 4 of them on your unit exam. Okay, so make sure you know how those work. And then make sure you're reading over your notes on solubility and reactions, polar nature of water, because there's some writing stuff on that in the written response. You need to be pretty knowledgeable and familiar with that so that you can answer those questions as well. Okay. What do you need to bring on Monday to your test? Calculator, okay? Can't use your phone, all right? Your phone will be in that bin over there. So make sure that you bring a calculator. And it needs to be scientific, most likely, because you've got to be able to put in Avogadro's number into it, okay? Pencils, bring more than one pencil. Okay, in case one gets dull or you break it or whatever, okay, make sure you have more than one pencil or lots of lead in your mechanical pencil, okay, something along those lines, because you definitely need a pencil for the multiple choice. I would suggest also doing the written response in pencil as well, especially the reaction stuff in case you need to erase something. Okay. And you need to bring your periodic table. Remember that I will be checking your periodic table over before the exam, okay, just to make sure you haven't written too much stuff on it. Okay? If you have, just grab yourself a fresh one. Okay? The thing you can have on there, as I said before, are the prefixes. Okay? If you want to write the prefixes from 1 to 10 on your periodic table, that would be fine. Yeah, I suppose if you want to have the Roman numerals on there, yeah, that's fine. I think you'll only need up to 4. So I, and IV, and you should be good. Okay. What you need to bring. Okay, I think that's everything. So just make sure, guys, that on the weekend, okay, try not to spend big blocks of time studying. Okay, the longer your block of studying, the more stuff you'll forget. Okay, short blocks of studying are better. All right, so you know what I always tell people is, you know, like watch a TV show as a break, okay, like take a half hour off or whatever, okay, and then study for like 20 minutes to a half an hour, okay, study one thing for that 20 minutes to a half an hour, get really familiar with it, then take a break, okay, that way your mind has time to commit it to long-term memory. If you just keep jamming stuff into your brain for a 3-hour span, okay, the only stuff that gets into your long-term memory is the first stuff and the last stuff, and everything in between you'll forget, right? So short blocks of studying, take breaks in between, short blocks of studying. Okay? That's the best way to get everything in there. And then Sunday night, get a good night's sleep. Okay, 8 hours of sleep. Okay, get a good breakfast. Okay, come in ready to write the test. Now, I think I mentioned this to you before as well, but I will let you start the test early. Okay, if you want. So we'll say I'll give you 15 minutes. So if you want to come in here between 1/4 after and 20 after, okay, I will let you start then. Because we always lose about 5 minutes with morning exercises, you know, national anthem and gospel reading and all that. Okay, so I'll let you start, say 1/4 after or so. Okay, so come on in and I'll give you your test and you can start then. Okay, when class is over, the test is over. Okay, there's not going to be extra time. You don't get to come back later and finish it. Okay, that's when you have to write it. Okay. All right, any questions about the test for Monday?